Welcome to ClickMyProject.com.
Project title is Monitoring the Impact of Peer-to-Peer Users on a Broadband Operator Network over the time. Abstract. In peer-to-peer system, computing and networking is a distributed applications architecture that participant tasks are workloads between the peers. Peers are equally prolinked equipment to participate in the application. This model of network arrangement differs from the client-server model, where communication is usually to and from of the central server. Most research on peer-to-peer streaming has been focused on the increasingly live peer-to-peer streaming. In this project, the system presents an adaptation for the classify the broadband users into a peer-to-peer and non-peer-to-peer group based on the amount of the communication partners they have in dedicated the time frame. In this existing system, the system has classified subscribers in the Japanese ISP backbone networks by the amount of data they transferred in a given time period into heavy and normal users, as they ought not between classify the customers into peer-to-peer and non-peer-to-peer users. The average bandwidth per users can be used as a 230 KB per second is not directly comparable to our results. Existing system and proposed system to overcome the scalability issues that arise when delivering the live stream to very large number of receivers. These approaches focus on building the efficient multicast overlay among receivers to effectively distributed and share the live video streams. In this process, it does not have the correlated well with a physical network. It decreases the possible gained bandwidth. It is a complicated. So to overcome this problem, we have to introduce the proposed system, classify the subscriber into peer-to-peer users and non-peer-to-peer users by the counting the number of hosts, that is the distinct IP addresses. The subscriber exchanging the IP packets with the during the defined time frame, and the presence and adaptation for classify the broadband users into the peer-to-peer and non-peer-to-peer users. It is based on the amount of communication partners they have in a dedicated the time frame. The system derived the impact on a network characteristics like a number of active users and the aggregation bandwidth based on these classifications. In peer-to-peer users are defined in the scope of this work as customers using the peer-to-peer software. The main application that use peer-to-peer technique is still file sharing over the internet. In this advantage they have is simply and practical. It allows the restricted data collections. It's more sufficient. It's against to the decrease the possible gained bandwidth. It can clearly derive that the metric of the peer-to-peer overlay network does not reflect the physical networks. In this process, we have to implementing the peer-to-peer and non-peer-to-peer systems. Next one is the flow diagrams. In flow diagram, there have been the network formation, neighbor estimations, and the construct the peer-to-peer streamings. The data will be collections. In network formation, the node will be deployed, and the neighbor estimation, we have to identify the neighbor node in between the source and destinations using as a distance formulas. Then construct the peer-to-peer, that is called as a peer-to-peer, means we have to connecting with each other node with wired communication. Next one is a data calculation. In data calculation, we have to measure the measurement, processing, and then measurement and processing. We have measurement means we have to declare as a measurement, say how much packet we have to send is and how much packet we have to receive. Next one is a processing. Processing field means then after that we have to data packet forwarding to the source to destinations. Then we have to analyzing the results. That's how we have to find the quality of service parameters like packet delivery ratio, throughput, delay, and then packet overhead. That's and all the packet delivery ratio. Next is a simulation. We have to click the root home button and then open the terminal, type as a command like cd space code. Then after that we have to change the directory to find out the list of files, and then write the command as a ns space then ss.tcl. After that we have to go, the program will be running over here. The program is running its process over. This will be the peer-to-peer communications. We have to select that a source to one source, two source and two destinations. In the source and destination we have to select as a relay node. Relay node means the in between the source to destinations which will be the shortest node. We have to select that node as a relay nodes. The program is running over, the packet loss will occur, then drop of the packet will be the then it will be dropping the packet. After that it will be reaching the destinations. After that it will be reach the destination using as a relay node. Then the routing path will be occurred here in between the source and destinations. After identification the routing path between the source and destination, the other route will be calculating as in this S1 will be forward the information to the S2, and then S2 forward the information to the D2, like in between the relay nodes. Then we have to form the running procedure will occur. It will be forward the informations. With this one is a peer-to-peer communication process. If you are running the TCL script means it will be automatically generating the outer trace and outer num in this backend of the process where we are stored the TCL script. It will be generating the automatically. In the outer trace we have to identify the simulation time, how much packet we have to send this and how much packet we have to receive. It will be using as the process. Then it will be the called as a peer-to-peer communication. In the 7th number node we have forward the information to 8th, and then it will be forwarding the information to the process. Packet will be dropped here in between the relay nodes, and then information will be forwarding. This the packet that blue color drop will be occur, that will be the packet loss. How the packet loss will occur means we are sending the packet, the capacity of the node will be the 1500 packet size alone, means we have to send the packet size 2000, means it will be losing the 500 packet. So to overcome this problem we have to introduce as a peer-to-peer systems, like a non-peer-to-peer system also, to overcome this conjunction process using as a TCP connections in between the every nodes. We have to analyzing the transmissions and then the after that we have to identify the graphs. Next one is the GNU plot space loss dot plot. We have to find the loss packet delivery ratio, then we have to find out the existing system and proposed system. After the GNU plot will be the packet delivery ratio, that is how much packet we have to send it and how much packet we have to receive it. Next one is here GNU plot routing overhead dot plot. Routing overhead means how much packet that forwarding the data transmissions in between the source and destinations. In that routing how much packet we have to overhead in existing system and proposed system, and compared to